Hi all, I discovered another property to the Wonder material. It catches on fire extremely well. This is the tub it was in. It all burnt. And how I burnt it was with that 9-volt battery, which is half dead. There's a 1.5 LED. If that battery wasn't flat, it would blow that LED. As you can see, it only lights it just, and it doesn't blow it. Well, I had that in the powder. I had one end in the powder here, and I was testing how far away I could light the LED. And I noticed some sparks happening, and then all of a sudden, the sparks turned into orange glows all around the material. I was able to reproduce it, and I've also discovered some other strange behaviour with this material. I'll get rid of this tub. I'm going to also try to reignite it in this bowl, but I've got a magnet here. I have some iron oxide as a comparison. There's a lot more iron oxide powder in there than it is in that flaky form of that, whatever that stuff is. That's that Wonder material. Right, so we've got this attached to a magnet. It sort of comes off with a bit of effort. It does have a bit of pull, but this material is lighter in weight than that lot, and it sticks to the magnet way better. So it's like super magnetic. I'll just put that over there and get rid of this magnet. Okay. So the material had me fooled. I thought it was carbon because it just feels like a piece of paper. But it bends back. It's quite flexible. It will crack after a while. It's thin. It's the stuff. I'll do the ohms test again. It's set on... Put it on the 200 range. Find a bit of material. Oh, not getting contact. Oh, I broke it. So the harder I press, yeah, it is the material. Alright, so we'll, I don't want to waste it all. I'll just tip some in here. Okay, hopefully, I'll just pack it down a bit. Might not have enough. It's got to be sort of in a tub to hold it. So I'll stick, this is the positive side of the battery. Just try to stick that in there. Okay, rightio, we've got our LED end. So we're lighting up. We might light up a bit better in a minute. But extremely conductive. Oh yes, there's a ember. That's how it starts. See that little ember? And then it just snowballs from there. Like, we're going to have a fire in a second. And then it was in that tub, so I was like, oh no, I'll take it outside. Let's go outside and see what happens when it gets a bit more air. I was like, oh, here it goes. We're just walking in it, burning up. And then so it's going to smoulder away. It's quite warm in there. This time I'm going to keep the ash. The ash might be something special. Yeah, that was just hot on my finger then. So, whatever this stuff is, it burns quite well. It's giving off some good heat. Oh, I'll get my probe. Hang on. Oh, look, 300 degrees. I better get some safety glasses on because that bowl might crack in my face. Alright, I'll leave that bowl there. So, you saw it yourself? Oh, can't see that. Yeah, so that's quite very amazing. Another thing I had noticed, I'll get that magnet again, is when I redid the carbon again, or the Wonder material, my bread this time turned into a 2 ohm bread with the probes, and can't quite see it. But there is bits there which sort of attract to the magnet. So I'm not sure if it's iron, but even in its powdered form, when that's set on the 2K, I know we got to do 20K because it's only powdered, got the probes taped together. Yeah, we're under, depending on the probe position, but it did get to 5K just in the powder. That was the bread. It was a lot more silvery, plus that was the second burn of that bread. I redid some. I used the bread I used in that experiment and I put it back in. And this time I tried something new. Potato and cauliflower. I had an old mouldy cauliflower. That was 2 ohms as well. This one's about the same conductivity. Maybe. Yep, probably a bit better. It's holding under the 1K sort of, or it was. So that was potato skin, a bit of potato, an old mouldy one, and a cauliflower what went all mouldy. Maybe the mould's key here, because the first batch also had 2 really mouldy scented potatoes. So that was the potato. The sugar one came out as well, much better. I tried a glucose and normal sugar, table sugar. So there is particles in there moving. And we should try to set that on fire maybe. And the ohms test on the sugar. This is glucose and the standard sugar. It's got less in there, but that's not a bad reading. It did drop down before then. And see if I can pack it a bit better. Probes have to be packed right under, up there. Oh yeah, there we go. It was a 300 ohms. Not too bad. And our standard bread. Oh, I have a 2 ohms bread. Oh yeah, we didn't do bread yet. This is the 2 ohms bread. That doesn't have any form of nothing going on with the magnet. Yeah, that's under. That's actually good. The bread works alright. Yeah, so I'm glad I didn't burn all of this stuff. Feel that pull, look at that, it just, that's taking a bit of force, and they're all lining up pretty good. Stick the probes in there while the magnet's on. We're getting 300, 200. Oh, yeah, 0. Woohoo! It's on the 200 range, I mean 2K, 20K range, so here, we'll go down on this one, 200 range. So yeah, what do you reckon? Oh, it's not getting a register, doesn't matter anyway. So what do you think of this? Is it hydrogen impregnated carbon, or is it just some sort of iron? The iron oxide is definitely not conductive, even on the 2M range. Google proves that too, says it's not conductive. And my electrode also, because I made an electrode and then tried to see if it was conduct resistance on it, and it was like, oh no, it's like mud. Yeah, so this material is very weird. I'm gonna wash my hands after this because who knows. Like, it doesn't feel like metal, it's just, but it sticks really good. And the magnet pull is really strong for what that is made out of. Well, something to look into. Yeah. And I couldn't find anything on iron 3 chloride being conductive on Google, but I only did like a brief check. See, it is a powder. That would crush up into a powder with your fingers. See? I probably don't want nanoparticle iron in my fucking system, do I? Alright, well, thanks for watching. I will be back. I'm back with the burnt stuff. It actually resembles and feels like rust now. It's going a bit harder. And it even has a rust-like appearance, and we're on the 200k ohms, and it's no longer conductive at all. Nowhere in there, unless I get it on that piece of copper there. There's a trace of that wire. And another thing, the LED, I hit that wire. LED won't light up. I hit the wire. See, it's live. So that's how you break the wonder material. Set it on fire and it turns back into, I guess, iron oxide. It's still magnetic, so it's kept that property. See, it's all lining up. Oh, get the light over there. But not so strong pull, really, but it acts more like the iron oxide. It crushes pretty easy. So there you go. I wonder what it's creating. Okay. Alright, thanks for watching.